BGP Part 6, Configuring BGP Attributes to Influence Routing Part 1. And it's kind of funny now that I say it that way. We have Part 6 and Part 1 of Part 6. So I guess you can think of this as Part 6.5. We're going to show you in this nugget how to tweak BGP so that it can have the best path to get to a specified destination. Now, BGP is going to get thousands, if not tens of thousands of routes coming in from the internet. You're not going to sit there and say, well, this one's preferred from this service provider and this one's preferred from this for all 10,000 routes that it's receiving. Now, instead, what you're going to do is you're going to choose some key routes, maybe routes to partner organizations or branch offices that you have VPN connections to across the internet, and choose the best service provider to use for those. I've also seen a lot of people wanting to have redundant service provider connections for incoming connections. For example, I just finished designing a network for a company that had two different service providers. Imagine these are entire service providers, and they were connected to two separate routers in their organization. Something like this. Now, one of those service providers is a primary service provider, and one of them is a secondary. The reason they wanted this sort of design is because behind these two routers sat the sacred web server. This company gets most of their business through a web enterprise style of company. It's an e-commerce company. Now, they wanted this service provider over here to be the preferred one. 90% of the time, they want people to come in through this one because they had a higher bandwidth connection. But if that service provider or that router or that link ever went down, they wanted this service provider to be used as a backup. Now, that's tough because now you're trying to start influencing other people's autonomous systems. How do you do that? I mean, how do you get this service provider to say, okay, I'm not the preferred one, when really that's not under your control? Well, I'm going to show you ways that you can tweak it, that if the service provider agrees with you and doesn't do anything, one service provider will be preferred over the other. That's the power we have with attributes. Now, in this nugget, what we're going to go through is these four major attributes. Number one, modifying the route origin. Where did this route come from? Was it redistributed? Was it put in through a network command? I'm going to show you how you can change that. From there, I'm going to show you adding to the autonomous system path. Yes, even the autonomous system path can be modified. You can change where it looks like a route came from. I'll show you some reasons why we'll do that, and then I'll show you how to do it. Finally, we will hit the most confusing part of BGP. Those of you that have seen these before know exactly what I'm talking about. Filtering routes using regular expressions. Now, those of you Unix people will probably enjoy this section. Me, I believe Unix is a four-letter word, and I try to stay away from it. So learning regular expressions for me was like pulling teeth. And I'm going to show you a nice, easy way to remember the most common regular expressions that you're going to be using when you filter routes. Finally, we'll look at adjusting the next hop attribute. Where did this route come from? Where is it going next? What router do I go through? All of those are manipulatable and tweakable using route maps with BGP. Here's the topology that we're going to use as we go through this BGP attribute configuration. Now, those of you that saw the BGP route aggregation nugget will recognize this and go, oh yeah, it's the same one. The reason I did that is, number one, you're probably already familiar with it, so you have a general idea of where things are, what IP addresses are where, and so on. But the main reason that I chose it is it gives us a lot of flexibility. We have redistribution from some other autonomous system over here, not really autonomous system, but OSPF network. We have multiple quote-unquote ISP-style connections going over to the right-hand side, so we're going to be able to do a lot. And the first thing that I want to focus on is that origin attribute. Now, if you remember, the origin tells you where the route came from. And it can be any one of three things. One, it can be I, representing the IGP. Two, it can be E, representing EGP. And three, it can be a question mark, meaning it is incomplete, it has no idea where this route came from. Now, as we discovered when we did the BGP route aggregation, when we redistributed from the OSPF network into BGP, all the origins go to question mark, because anytime you do redistribution into BGP, it will immediately say, I have no idea where it came from. Now let's go back to that chart showing what BGP routes are preferred. This is the one I was talking about, where we go through the route selection criteria. So the first thing I want to do is define why we're changing the origin. If you look down here, you see, choose the one with an exclude routes with inaccessible next hop, prefer the highest weight, local preference, and so on. As you go down this list, you'll notice that most of the time, things will be equal. Where we start getting into the differences is where you start hitting the shortest AS path, and if that's tied, the AS path is, what's the next one it relies on? The lowest origin code. IGP beats EGP beats incomplete. So by setting the origin, you can tweak which routes are more preferable than others. I could send routes to one internet service provider that have an origin of I, and routes to another service provider that have an origin of incomplete. I used I for both of them, or question mark in this case. What that will do is it will say one is going to be preferred over another. Now, most of the time, you will be sending the same routes from maybe two different routers. Let me draw a topology on the bottom of this route selection criteria here. You might have two different routers that are connected to the same ISP from your company. Maybe you have that local area network behind there. You might send some routes from this one with the little I attribute, saying these are all IGP learned, and this one being a question mark. This internet service provider gets it. It looks at the autonomous system path to break the tie first, and it goes, oh, the autonomous system path is equal? Well, let's jump down to the origin code. Aha! This one over here is going to be more preferred, and what have you just done? You have inadvertently told the service provider that it should go through this router anytime it's trying to reach your network rather than this router over here. That's great if you have multiple routers connected to the same ISP router, because you can influence them without them really even knowing what happened behind the scenes. You don't have to work with their administrators for this, provided that they are factoring in the lowest origin code and they're using the default BGP standards to choose those routes. So here's what I'd like to do. Go ahead and put on your imagination caps a little bit. Imagine that router 3 and router 5 back here had some sort of dual Ethernet connection, that they were connected on the same network. Maybe this is the same ISP, just two different entry points, or maybe it's just two different ISPs that somewhere down in the mix have some sort of connection to each other. What I want to do is I want to set half the routes. Let's go ahead and bring up router 1. I want to set half the routes on router 1 to have an origin attribute of I over here, and the other half to have I over here. Now, I have a nice divide. I have half of them being 172.x.y.z networks, where we have 172.16, 22, 32, and all the way down the line. So I'm going to say these I want to be I over on router 3, and the rest of them I want to remain question mark. For router 4 down here, I want router 4 to receive the other half. We'll say 192.168.x. All of those routes should be tagged with an I on router 4, so they'll be a little more preferred. And then over here will remain a question mark on the 172 networks. So here's how we do it. And there's different approaches that you can go about this. I'll show you my preferred way because I just like working with access lists. I'm going to do on router 1, I'm going to type in access lists. Let's go ahead and use 60. And I'm going to say permit 172.000 with a wildcard mask that looks something like that. So from there, I'm going to do access lists. Let me go ahead and do access list 61. I'm going to have two separate access lists. And the other one will permit all 192.168 networks as well. Now remember, end of every access list is implicit deny. Just want to make sure you remember that, because now we're going to come into the route map configuration mode. I'm going to say route map, and let's name these logical. I'm going to do R3. And for router 3, I'm going to say match. And there's many different ways that we can match it, and we're going to start using a lot of these different methods as we get into the different types of attributes. But I'm going to say match, in this case, the IP address. So I'll do IP. And by the way, one of my other favorite ones is, you see match route type. I can go in there and I can say what type of route I want to match, and based on what kind of route it's tagged as, most of the time I end up using local for anything that I include with the network command, but that allows a lot of flexibility as well. But I digress. I'm going to do match IP address, followed by the IP address of the first access list, or the access list number of the first access list. Now this will be the one that permits 172 to be tagged. So I'm going to say match IP address 60. From there, now I'm going to get into the attribute setting. I'm going to type in set, followed by, and right there's our attribute, origin. Origin, and I want to set the origin to be IGP. And it's funny because a lot of times when you first learn BGP, you look at all these AS path and origins, and you think, oh, okay, these tell exactly where the route came from. Well, it may, but it may be some administrator playing with your mind as well, because if you look at this set list, I mean, let me scroll back up, just about anything can be changed. Your AS path, your community, we'll talk about that in the upcoming nugget, or what level you're importing into, the IP information, like the next hop, the origin, everything can be changed using these route maps. That's why they're my preferred method to do just about everything. So let me just do a show route map. I'm going to make sure that I have, indeed, router 3 is the name of the route map, and I'm going to match 60 and set the origin to IGP. Good. Now I'm going to create a route map called R4 for the other router. And I think you're going to follow where I'm going with this. Match IP address, and I'm going to do 61, set the origin, got to spell it right, origin to IGP. Now, the last thing that I need to do, jumping all around, I'm going to go into the BGP routing process. 7500 is what autonomous system router 1 is in. And I'm going to go under the individual neighbor statements for these routers, router 3 and router 4. So I'm going to type in neighbor 10.13.1.2. That's router 3. I'm going to do route map. R3 was the name of it. Out. Hit the up arrow. Change this to R4. Change this to 14, which is the link that comes down here to router 4, and there's its IP address. So I'm going to change that, set the route map, clear the IP BGP neighbors. And what I'm going to do is I'm going to pause the video because it's going to take about 45 seconds or so to come back online, and then we'll jump over to router 3 and router 4 and check out the results. There they are. They've come back online. Now let's hop over to router 3. Well, first off, again, let me do a show IP BGP on router 1 and show you the origin is question mark because all these routes are redistributed. So they're going to stay question mark unless I modify something in there. So let's hop over to router 3 and do a show IP BGP. And what do we see? We see these 3 routes that are all permitted and set to an I. Yikes. What happened to the other routes? Well, let's hop over to router 4. Show IP BGP. They're over here. We've made a mistake in our route map. Here's what we did, and this is something I wanted to show you to make sure that you can catch this. We did on our route map, I'm going to do a show route map on router 1. We said I want to match this access list and set the origin. However, we never put in another sequence number that let the other routes pass. See, route maps can be used for plenty of things, and unless we create a sequence number that says, okay, the other routes can pass through, we're going to be stuck in the mud because it's going to actually cut those networks from our advertisement. So what I'm going to do is I'm going to add a statement to each one of those route maps that allows all the networks to pass to each router. It is very easy to do. So let me do a show route map right here just to show them again. We currently have those access lists that are the only things that are allowed. So this route map is not only tagging those with access list 60 with the origin of IGP, but it's saying implicit deny every other route is blocked. Global config mode. Here is how you do a permit any for a route map. I'm going to type in route map. Let's do R3 first. Permit, and I'll just do sequence number 20. I just added another sequence number, and it says permit. That's it. Route map, router 4, permit 20, and it could be any sequence number after 10. And that is it. I'm going to do a show route map. And while I do that, let me do a clear IP BGP star. That'll wipe out our neighbor relationships, but notice what happened. Right up here, I have route map R3, sequence 10, here's our access list. Now sequence 20, you see the match is nothing, set is nothing. Essentially what this says is just anything, allow it to go through. It's the same thing as doing a permit any in an access list, and I've added that to both of these. So when these neighbor relationships come back up, we should see now not only the routes that are set to the origin of IGP, but we should also see all of the routes that are not set to an origin of IGP, the ones that have still an incomplete origin. So there we go. We've got our neighbors coming back up. Hop over to router 3, show IP BGP, enter. Oh, that looks much better. Take a look at that. And our route map is working. 172.16, 22.33, they're all coming from I, whereas 192.168 is coming from question mark. Let's hop on down to router 4, show IP BGP. And look at that. Exactly the opposite. So we can tweak these attributes to be essentially whatever we want them to be. It will tell us where those routes came from, but we get to dictate that. And we have our 3 options that we can be flexible with. So if these things come in, now again, this is typically used where we have a single ISP connection. But let's say down here, router 1, we went ahead and set it for router 4. The ones that are sent to router 5 and router 6, it's going to look at those origins and go, oh, wait a sec. I have one that has an origin of question mark and one that has an origin of an internal gateway protocol or interior gateway protocol. I'm going to prefer the ones that have IGP over the question mark. So that's how we can tweak the origin. Now let's move on to the next one, which is modifying the AS path. And this is going to be the most common option that I've seen. We have on router 1 all of these routes that are coming in from the OSPF domain. We can tweak the AS path to be totally different for each ISP that we send it to. Here's why that's great. The origin is fine and dandy when we're sending it to a single ISP. What I did right here was great. It demonstrated the concept, but really that's typically used if we have 2 routers in the same autonomous system. If you are doing like most companies do, they not only buy redundant service provider connections, but they buy them from different service providers. So that way they have redundancy between service providers. If one service provider goes down, the other picks up. But we want to have maybe our primary, let me grab my pen over here, our primary service provider and then our backup service provider. We want this one to have all of the traffic coming in from the internet going this way to reach these networks. And then this one is, I'll put a little arrow with a 2 around it. That's our secondary connection. That only is used if this primary is down for incoming traffic. The way that we can best gear that is by changing the autonomous system path. Again, let's go back to our BGP attributes. What you can see looking down this list is that we're going to have a lot of attributes that are checked, but most of them will be tied by default. Prefer the highest weight. Well, unless you set the weight, this will always be the same. Prefer the highest local preference. Unless you set that, it will be the same. Prefer routes that the router originated. Well, unless you're sitting on that router and you did this with a network command, that's going to be the same as well. So typically, the common decision criteria that we use is prefer the shortest autonomous system path, which is essentially autonomous system hop count. Only the length is compared. Now, looking back at our topology, let me switch over here to the topology. We see that router 1 is going to be sending it to router 3 and router 4. What will the AS path be for both of those routers? Well, it'll look like just 7500. It will be exactly equal for both of them. So what we need to do is we need to make that AS path longer for our backup ISP. Here's what the whole picture looks like. If this picture could go a lot bigger, I mean huge, we would see these ISPs connected off to other routers in the internet and other autonomous systems that spans the entire globe. And it's going off the right-hand side here. What will happen is your route, all these routes that we have over here, 172 and 192.168, provided they would be real public networks, they would propagate through the entire internet. One with a less preferred AS path, one with a more preferred AS path. Now, if this one went down, if this whole service provider went down, what's going to happen? Well, all of those routes with the more preferred AS path will disappear. Yes, it will take some time. BGP is slow to converge. However, they will eventually disappear, and then all the routers on the internet will say, okay, I now have one that doesn't have as good of an AS path, but you know what? A quasi-good AS path is better than nothing at all. So it will end up using your backup internet service provider connection. So now the question becomes, how do we change the AS path to be more preferred for one rather than the other? Well, the way we're going to do it is through something called AS path prepending. AS path prepending will literally add AS numbers to the front of your autonomous system string. So when router 1 sends out advertisements to router 3, we'll have less autonomous systems on the string than router 4. So router 4 will have a longer quote-unquote hop count to get there. So as it propagates those routes through the rest of the internet off the right edge of the screen here, all of those routes will look less desirable to all the routers than this one, which has a shorter AS path. So let's hop onto router 4 or router 1, and I first want to blow away all the route maps that we used for the origin. I'm going to get into global config mode and do a no route map R3, no route map R4. So we're starting from scratch. Now what I want to do, before we get into the route map, I'm going to do a show IP access list to see what we have at our disposal. And it looks like we have 60, which specifies 172 networks, 61, which is 192.168 networks. Huh, I just thought of something. This would be really cool. What if on router 3, we made router 3 the primary, but only for 172 networks, and have it be the backup for 192 networks. And then down here on router 4, we made it the primary for 192 networks, and the backup for 172 networks. That way, oh, this is brilliant. That way, by sending those out, we'll have some of the primaries going through this service provider, some of them going through the backup. We aren't having, at that point, a link that's just left idle. This backup link will be utilized. It's not just idle bandwidth sitting there. It will be the primary for half of the networks. Now, I just kind of shot from the hip on that one. However, in a real network, you would definitely need to make sure you do some traffic analysis, make sure 192 isn't getting 90% of the traffic or something like that, and really divide that up equally. And thankfully, we already have those access lists created that will allow us to do that. So let's do this again. I'm going to go into router config mode, global config mode, and create a route map. And we'll name it R3 again, just to keep it nice and logical. And I'm going to match IP address. And what I'm going to do is I'm going to match 61. Because I don't want to change any of the AS path for the 172. I want it to be the best possible AS path that I can get. I'm going to change it for the 192.168 networks to make sure that this is chosen as a backup over this one. So I'm going to say match IP address 61, and I'm going to set, here's the option, set the AS path. Now notice, you're not able to strip the AS path completely and redo it. It's just allowing you to prepend strings to the AS path. So I'm going to type in set AS path, and then I'm going to say prepend, and I get to type in the AS number. Now you might think, well, what AS number are you going to prepend? Well, the answer is you could prepend anything that you wanted to, but be careful. If you ever prepend, let's say you just make up a number. You say, well, I want to prepend 10,000. I want to prepend that number to it. Well, somewhere out there, there may be autonomous system 10,000, and when it gets your routes, you know what it's going to do? Drop them. Because it's going to say, oh, hey, my autonomous system's already in the path. So those must be looping routes. That's the loop prevention mechanism of BGP. So instead of putting a real autonomous system number, what you should do is use your own. Yeah, it sounds a little weird, but this is what it'll look like. I'm going to say AS path prepend. We're on router 1, so our autonomous system is 7500. Prepend 7500. Followed by 7500. Followed by 7500. You might say, well, where's it going to end? Well, I'm going to prepend 3 7500s to it, so the AS path will have 3 extra 7500s than it would on the bottom. Yes, you can have duplicate AS numbers in the AS string as long as it's your own system. Because once it leaves your system, it should never come back to that, or else it would be considered a loop and it'd be dropped anyway. So let me exit out of this route map, and I'm going to do the show IP access just to make sure we have that on the screen. Route map R4, and I'm going to do a match IP address, and we wanted router 4 to be the primary for 192, so I want to make 172 not look as desirable, so we're going to have 60. Set AS path prepend, and I'm going to say 7500, 7500, 7500, 3 times. Now I don't want the same thing to happen that happened before, so I'm going to make sure I type in route map R4 permit 20 just to allow that permit statement, and also do it for router 3. That'll let all the other routes that don't match those access lists to flow through. Remember, it's just like the permit any statement. I'll do a show route map. Well, before I do that, let me clear those relationships so they're already started. And to do a show route map and verify what we have here, I have R3, which is matching 61 and prepending those 3 numbers. And then we have the permit any. Route map R4, which is matching access list 60 and prepending those 3 numbers. And then we have the permit any. Now, if I'm correct, we should still have the route maps applied to the neighbor, and they are. So that reset will take just fine because the route maps are still applied. We just pretty much gutted the route maps and started over. It looks like our neighbor relationship is up. Let's hop on over. Let's see if the magic worked. Over to router 3, and I'm going to do a show IPBGP. Look at that. That's awesome. We've got router 3 that has the 172 networks with a path of just 7,500, and look at all the 192 networks. 4 7500s because I prepended 3 of them using that route map, and then we have the original 7500. So as those are passed in this autonomous system and to all the other ones, who do you think is going to be preferred? Well, let's hop on down to router 4, show IPBGP here, and what we see is just the flip-flop. Of course, this autonomous system down here, router 4, is going to be the preferred for 192, which is exactly what we wanted. It will be the backup for the 172 networks, and that's where we have up here the primary, the preferred for the 172, and those are allowed through. So mission accomplished. We now have better networks from one autonomous system than we do for the other. Okay, let's just do a progress check just to make sure where we are, and so I can see which one to do next. We have modifying the route origin. We took care of that, and you can change that for anything. We added or prepended to the AS path, and I would say out of all the things I've been asked to do most in the real world, setting up customer networks, this is the #1 thing, because most customers do not believe that you can have a preferred path over another coming from different service providers. A lot of documentation on the internet suggests that it can't be done. And this is actually one way that you can do it. Now, it's just one. There are multiple ways, because you may find a service provider that does not factor the AS path in their decision criteria. And you'll have to actually talk with that service provider to find out what they do factor so you can tweak that. Now let's hit one of the more confusing ways of filtering, blocking, allowing, tweaking, adding, modifying your BGP updates, and that is going to be using regular expressions. The problem is that these expressions are anything but regular. They're just odd. And as I mentioned, those of you who are Unix folks will find you feel right at home with this stuff because it was borrowed from the Unix world. However, these expressions, to me, when I first saw them, were totally new. But I have found over the years that they have really helped in filtering a lot of what BGP gives you in those updates. Now I'm going to bring up a router prompt, but here's kind of a thought. Those of you that have used DOS back in the day, where you've gone into DOS and you wanted to see every file that started with maybe .bat, all the batch files, what would you type? If you were sitting at a DOS prompt and you wanted to see all of the files that started with .bat, well, you would type in dir star.bat, right? Because you had this wildcard that you could use. Or if you were looking for your executable, star.exe. You had this wildcard that is the star. Well, that's what regular expressions are, except they are not as easy as a star, and they give you a lot more flexibility than just listing everything that starts with XYZ. Now, I went ahead and I advertised on router 5 this 10.50 and 10.60 network into the BGP table, and that of course quickly flooded the whole network, so everybody now knows about those two networks. If I'm on router 1, and imagine that we're in the real world, if I just went on router 1 and did a show IP BGP, what would happen if this was the real world? Well, I would see the entire internet routing table if I was receiving this, and I would have to hit space, 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 and I'd be scrolling for days to try and find the networks that I'm looking for. So maybe I just want to see the networks that originated in this autonomous system 2500. What I could do is do a show IP BGP, regular expression, followed by the expression. Now I'm going to use one of my symbols here. I'll do caret 2500. And what it will show me is just the networks that start with autonomous system 2500. As a matter of fact, that is just one of the many wildcards that you're able to use. So let's officially introduce it. The caret means, the regular expression with the caret, this wildcard means it begins with this item. And it's always used at the beginning of an expression. So for example, if I typed in caret 5, it means my autonomous system path, that entire path, has to begin with the number 5. So it would match an AS path that looked like this, 5, 10, 15, 20. Since it begins with a 5, it will match all of those. Now you might see this one as well, and you go, well, wait a second, that's not a 5. Yes, it is. These regular expressions are very finicky because it will match a 5, whether it be a 50, a 500, a 5 million. It will match any one of those because it starts with a 5. Now you might wonder, well, why do we even use the caret in the first place? Can't you just do like a show IP BGP and just put a 5? What would happen if you did that? Or, sorry, I forgot the one keyword. Show IP BGP regular expression 5. If you did this, it will show you all the routes in the BGP routing table that have a 5 anywhere in the autonomous system path. So it will match this autonomous system, this autonomous system, this autonomous system, and, oh, my pointer gets a little carried away, and this autonomous system. You're going to end up with routes showing up that you didn't think you had because it's looking for a 5 anywhere in that entire autonomous system path. So the caret definitely filters it down. It says it has to begin with the number 5 or whatever you want to begin with. But even that doesn't give us all the flexibility that we need. You may need to rely on the regular expression of a dollar symbol. This means ends with the item. It's the polar opposite of the caret. It is used at the end of an expression. So if we typed in $500, we did a show IP BGP regular expression $500, we're going to see all the things that end with 500. But be careful. Remember, if you have something like this, what do you think about this? Would this string match? Let's say 50, 785. Let's do 8500. Would that AS string match? Absolutely, because you can see 500 is right at the end. Even though we typed in 500, it's still going to match anything that has those numbers at the end. So you might even want to do something like this. This says it begins and ends with 500. Here's what this one means. It means only look for routes that have an AS path that only have 500 in that path list. So let me jump back onto my router and clear off this screen. What I did was I advertised a couple routes from other autonomous systems in there. I'm going to do a show IP BGP. Let's do regular expression, and I'll put caret 2500 $. And that will focus in on routes that only have 2500 in the autonomous system path. By the way, regular expressions do not encompass the origin, which is I, E, or question mark. It's only the autonomous system numbers. So this will only focus in on those routes that have 2500 and only 2500 in the string. This is great because we're able to focus in on just one autonomous system, and we can say, I either want to see routes or not see routes from this. You know what? Before I even go on with the rest of the regular expressions, the common wildcards, let me mention that I am using this right here, where I'm filtering what I view in the BGP routing table. However, these regular expressions can be used anywhere in BGP. Let me show you this. I'm going to get back into that route map that we've been using up till now. I'll do route map R3. Let me just use sequence number 30 because I'm not using that one. And I can match routes based on a regular expression. I can say, you know what, I want to match routes that have the AS path that's listed right here. Now, if you look at this, it might not look what you think it looks like. It says, I need an AS path access list. So you might say match AS path access list 1. Let me show you what it looks like. IP AS path access list is going to be a list that just specifies a regular expression. So what I can do, I just want to make sure you catch the big picture here, is I can match everything, we'll say that it started and ended with Autonomous System 500 and then set its origin or set its metric or set, all of these attributes that we're going to be focusing on to whatever. So regular expressions are used not just in filtering down the BGP routing table. If it was just that, I wouldn't say it's such a big deal. But by using it, you can use it to match anything. You can match any autonomous system that a route has traveled through. So that's the true power of regular expressions. And that is the $sign. The period wildcard is to match any character in the string, including a space. And if you guys tuned into the voice over IP nugget, it's the same thing as creating a dial peer that has periods as its destination pattern. It's just a wildcard that matches any character. So what we see here, I put a couple examples. We put $395 So what that means is that it ends with, and this is kind of a funny configuration here, because it's saying it ends with something 395. Now that could be a space, so it might be something like, just 395. It might be something like 1395. But the problem is before we don't have anything specified. So frankly, this could be anything. Just anything that has 395 as the last three. The dot really doesn't make much of a difference at this point. Right here, however, it does. What I have is that it starts with .395. So it can't really be a space because you can't have a space starting an AS path. But this could be, 1395, 2395, and so on and so on and so on down the list all the way up to 9. So anything that starts with something 395 will be matched by having that period wildcard in there. If I were to have to designate an MVP wildcard, it would be this one. The most important player in the BGP regular expression list, it is the underscore. It matches the beginning of a string, the end of a string, and a blank space. Any one of those three things, and there's actually a couple other things, and we'll look at those when we look at the brackets. But this matches just about anything. You might think, well, why is that so useful? Well, the reason why is you could have things like this. And let me show you kind of the alternative. I've been showing you a lot of wildcards up till now. And let's say, for instance, the caret. I put caret 50. Now, that's nice because it says the AS path must start with 50. But here's the problem. The AS path could be 50 space something. It could be 500 space something. It could be 501, 5009. It could be anything as long as 50 were the starting digits. So what we can do is we can say, you know what? If I want this just to be 50, to start with the autonomous number 50, I would put caret 50 and an underscore. That says it's either the end of the string or a blank space, or the beginning of the string, which we specified right there, so it can't be that. This will say just match 50. Oh, did I put 50 twice? Unbelievable. Let me go ahead and just match 50. Just that one AS number. Because it could be an AS path that just had 50 in it. It could be an AS path that had 50 space some other autonomous system over here. Who knows what that is? As long as it starts with 50, it's good to go. The underscore says this has to be either a space or the end of a string in order for it to match. That keeps us from matching these weird ones in between, the autonomous systems that we may not have caught. The most often use that I use for this one, most often used, how about the most common way that I use an underscore is something like this. I might say I want to match anything with autonomous system 1270 anywhere in the string. That's where we have it either starting with, ending with, or being somewhere in the middle. That's the blank spaces that it could be, autonomous system 1270. I have right here starting with or ending with autonomous system 10, or being somewhere in the middle. It's the ultimate wildcard because of its flexibility. So if any wildcard that I would say I use most, it would be definitely the underscore. The final regular expression wildcard that I want to talk about is the brackets. By the way, the underscore can also match a bracket, and that's why I wanted to wait on saying that until I got to here, because the brackets define a range. Here's the idea. We could put 1 through 9, 5, 6, 7, and what this would match is any autonomous system that was 1, 5, 6, 7, or ending with 1, 5, 6, 7, 2, 5, 6, 7, and so on, all the way up to 9. That's what the through character means. Now, remember, unless we started this off with an underscore, just like we saw, this could, it could match 5167 or 42567. So we got to put that underscore there to make sure that we have a space before this ends the AS path. Here's another example. Caret 5, 1 through 5, 6 is a little more filtered. I'll put an underscore right after that to make sure it's a space. This would match autonomous system 516, 526, 536, 56, all the ones 1 through 5. This one I put on here because it's a funny one, but I want to make sure you catch it. 7, 1, 2, 5, 9, 1. Huh? Imagine when you see a bracket like this, that there is commas in between. This will match, and let me put an underscore after it to make sure it's a space. 7, 1, 1, 7, 2, 1, 7, 5, 1, and 7, 9, 1. It's a weird way to do it, but it's a great way to match, in this case, 4 autonomous systems just using one regular expression. Again, you can't put a comma there, but just imagine that there are commas anytime you see a bracket with numbers directly between them. Now, these are the most common regular expressions that you can have. And the nice thing about them is you can use them to match just about anything in the AS path. There is a regular expression that I've seen all the time. Let me bring it up on the live screen to show it to you. I might create an AS path access list that permits a regular expression that looks like this. Caret $. I might go, well, wait a second, what is that? That is an AS path access list that permits only things that have an empty AS path. Let me jump back to router 1 and do a show IPBGP. I might want to say, you know what, let me bring up the topology in the background. I might want to say that router 1 can only send routes out that originate in its autonomous system. Here's the big picture on this. We have all of these routes that I highlighted that have an empty AS path left. They don't have one yet. So if I applied a filter that said I'm only allowed to send things that have an empty AS path list that start and end with nothing, these routes will never get sent. This is a very common thing. Because imagine that your autonomous system is connected to 2 service providers. Well, imagine this. What would happen? What would happen if this service provider started advertising this network and this network to you? Well, it would come to you, and what would your BGP router do just by its nature? Well, it would send those routes over to this service provider. We'll say this is service provider 1, service provider 2. And you know what you just became? A service provider for the service provider, because you are advertising these routes as your own. You're saying, you know what, they're just going to come through here, and the autonomous system path might look something like 7500, 2500, question mark, because we redistributed those in, or I, depending on what it is. And this service provider goes, oh, wow, you know what? I just have a great new route that I can reach those with. And you just became a transit autonomous system. Oh, the service provider is going to use you, even though you're paying them for service. They're going to walk all over you to get to this autonomous system because, by golly, you have a really short path to there. So by putting this AS path access list of saying only send routes that have no autonomous system, you keep routes from going through you. You keep yourself from becoming a transit autonomous system. That is why these regular expressions can be so powerful in filtering out those autonomous system numbers. The last thing I want to talk about is adjusting the next hop attribute. And don't worry, it'll be a quick one, because the next hop attribute we've been adjusting all along. The idea is that you can adjust the next hop attribute. How do you do it? By using the next hop self command. 90% of the time, that will be all you have to do. Oh, let me get the right window up here. Is just make sure that you adjust the next hop to be something that's reachable. Now, the reason I want to bring it up in the attribute section, even though we've been using that next hop self in BGP all along, is because you can adjust it using a route map as well. And I'm not going to do a full demo on this because you can find different uses for this all the time. But I'm going to go into the route map configuration mode. I'll do route map R3. We'll just do sequence number 60 just to give us a line item. And I can say I want to match, well, let's use that AS path that we just created. I want to match the AS path 1. the access list that says it has to originate in the system. And notice you can match many of them in one statement. But I can say match AS path 1 so it's originated, and I want to set, and the option is under IP, and I can say the next hop. So I can set the next hop address. We've been using next hop self to be kind of the default. So anytime we had an IGBP error, because it doesn't change the next hop, I would just say for router 1, next hop self. So it would use itself as the next hop, and all of the routers could reach that next hop. However, I could adjust it to be whatever I want it to be. Just type in an IP address and you can set the next hop for any group of routes that you can match using an access list, using AS path, using any one of these criteria. The next hop is totally customizable and adjustable. If you ever plan on setting up BGP in the real world, I would almost want to say keep this nugget as an archive, because it is one of the most common things that you have to do when you're setting up BGP for a company, to choose some paths over others. And what we've done is we've, in this nugget, talked about changing the route origin, changing the AS path. Those are the most common ways to say to service providers, these are preferred ways into my network. Now, if you remember way back to the nugget where we discussed all the BGP attributes, we saw that the metric, or the MED, is one of the ways that we can suggest to a service provider a preferred path into our system. However, a lot of service providers do not even factor in the metric or the MED in their calculations. These are ways that we can mess with the service provider's calculations, sometimes without them even knowing about it, to get a preferred path into our network. We also looked at a huge concept, which is filtering using regular expression, and I showed you the most common wildcards that you can use with regular expressions to, number one, filter down that BGP routing table so you can only see a subset of that enormous routing table. And second, because you can use regular expressions to match just about anything using an AS path access list. Finally, we saw the adjusting the next hop attribute, not only using the next hop self, but using a route map to adjust it to any IP address that you want to. I hope this has been informative for you, and I'd like to thank you for viewing.